One last and kind of easy example is just from the sketch. I got a picture of this function. Identify any relative extrema or saddle points. And what a function we have here. X squared plus 2y squared times e to the 1 minus x squared minus y squared power. How interesting. And if you look at this picture, you should see a maximum here and a maximum here. And it looks like a maximum value pretty close to 2. And it looks like x is 0 and y is negative 1. And also at x equals 0 and y equals positive 1 is where we have maximums. And let's see, x is 0, y is plus or minus 1, that would make this 2, so we got 2 times e to the 0, so maximum value of 2, just as I described, right? And a minimum value looks like it would be at the point 0, 0, and of course if you put 0 in for x and y, the whole mess is 0. 0 times e to the 1, but who cares, it's still 0. And it does look like we have a saddle point here. I'm looking at it, it looks like maybe at x equals 1, y equals 0. At x equals 1, y equals 0, we have e to the 0 again. X equals 1, y equals 0 would make this 1 times e to the 0, so 1. So the saddle point is at the point x is 1, y is 0, z is 1. And there's also one at x equals negative 1, y is 0, and e is 1. So from just examining this picture, we can see 2 relative maximums, 1 relative minimum, and 2 saddle points. Pretty cool. I wonder what would happen if I mess with this a little bit. If I made this a 3, well then it would switch it all around. We could again examine maximums and minimums there if you wanted to. I didn't mean to do that necessarily and make it part of my example, but it's just something we could do. So I really very much appreciate having graphing software. Like I would suggest to you, if you really want to see these things after you find out maximums, minimums, saddle points, there are a plethora of three-dimensional graphers you can find on the internet. Some are downloadable, although watch out for viruses, and some you can just do from a browser.